So, welcome everyone to CAD 101. We are going to be looking at how to start our journey into the CADing universe and how to get to know all these kinds of softwares that are very useful in the aerospace industry, very useful in the entire mechanical engineering industry. And you are going to see like a lot of it in your classes, in other projects. So this is where basically mechanical designs and much more actually, even electrical designs or aerodynamics designs. This is where it all starts. So it all starts with inputting a geometry into our computer, and that creates a model that we can then use to make a bunch of other things that are really interesting, and they do allow us to go much further into our engineering design. So here, let me just share my screen. All right. So just to confirm, can you see the screen right now? The slides?
Yep.
Sounds good. All right. So today we're going to be making our first part, and we're going to be looking at the team conventions and also the good practices. So just like in any other engineering design, we want to make our CADs as understandable and as easy to get as possible, just to make it easier for anyone else who's going to be working on it. So we are making a big team project, so we need pretty much everyone to be on the same page. So this is why we're going to be looking at team conventions and good practices. All right, so on the agenda, we have how to access NX Student Edition, which is a free version of NX for students. It is slightly different to the normal NX licensed version, but we are soon to get an actual license. As of 2022 and 2023, we are very soon to get the design team status, which will allow us to get a licensed version of NX on the McGill IT computers. And from there, we're going to be able to pool up all of these licenses and have a lot more access to different kind of software. So it's this is pretty much a first step, but it's all of the same concepts and all of the same, pretty much the same interface. So this is where we're good to start. Then we're going to look at how to create your first part. We're going to look at the good practices, and then we're going to look at the team conventions, because we do have certain things that we want to keep on check for everyone on the team, just to make sure that everything is going according to plan and that it's easy to find in our inventory and so on. We're going to look at what's going to be next for CAD 102. And then if you have any questions, we're going to be able to look at those. So what is a CAD? So a CAD is basically, again, a computer-aided design, which is a shape or a modeling technique that we can put on our computers. And from that model, we can then get a lot more information that is very useful to the design process. So we can get stuff like, on the very basic stuff, we can get center of mass, we can get the weight, we can get just the actual like design intentions, or we can get like the manufacturing planification and so on. If you are in mechanical engineering, you will learn about it in Mech 290. You will also learn about drawings by hand. So those are a bit different. I think it's in Mech 289 if I'm not wrong. But anyways, you will see this kind of process in your classes as well. So it's a good way to, if you haven't taken any classes like that yet, it's a good way to get right above the requirements, and it makes it a lot easier to pass that class afterwards. So for example, in any kind of design teamwork, we're gonna be doing pretty much everything that's gonna be done in that class, but in about half the time. So it's really a good way to not only get to know the actual engineering process, but to get ahead of your classes. So the most popular CAD softwares include stuff like Siemens NX, SolidWorks, ANSYS, CATIA, and a lot more. So we at McGill usually use softwares like SolidWorks. So if you are going to take Make 290, you are going to see SolidWorks as the main software being used. In our team, we are using NX as a preferred software because they have the potential to sponsor us with much more advanced software that can do finite element analysis and stuff like computational fluid dynamics. All of those things will be looked at later on in our tutorials or in some trainings that would be more specific. But in short, NX gives us a bit more freedom for us students. So this is where we're going with it. If you don't have the NX Student Edition yet, here is the link to access it. It will be posted in our trainings folder, and depending on the year that we're seeing this, it might be in different folders, but we are going to try and keep it all those years in the training section. So for now, we just use the student edition, but later we are looking at licensed versions. There are some slight differences, but honestly, nothing too complicated. So to get it running, you first download here. Actually, we can try and go on the link itself. So this is what we see on the main page. We can go over here to visit our download page here. From there, we can say get the NX Student Edition, but at first we do have to create an account. Once you do that, this is where you can download the software, and it will lead you to a page like this. And for me, I'm on Windows currently, so it does look like a Windows installation schedule. But if you are on, excuse me, if you are on Mac or if you are on Linux, it might be something different. So just keep in mind. And then once you download it, it would look something like this over here. So it does look like here, this kind of extract zip folder is done. So you can then just right click and click extract all. It will give you a folder like this. And once you get this, you can go in it and find the, hold on, the Siemens NX Student Edition.msi. So this is a Microsoft installer. This is how you get it installed, and in the end, it should appear on your tab as this thing over here. So this little icon as the Student Edition. So now we can start actually CADing. So this is where we look at the interface. So as you open it, this is the first thing that you're going to see. I did make a practice part for you guys in advance, so we are going to look at how to make this in multiple different ways. So this is the interface. Over here we have our main functions like the file functions, like creating a new file, opening a file, recently opened parts. So these are the recently opened parts. And this ribbon over here will be used later on during the assembly section. So we're not going to look at this yet. This square over here, this large main part of the interface, is going to be our visualizer. So once we have a part, this is where we're going to be able to play with it. We are going to have, on the top ribbon, you are going to see some other tabs, including tools and view and so on, once we actually create a part. So now we can start actually CADing. So here it is opened. So this is the visualizer, and to move around in the visualizer, if you want to rotate the part, you can click on the middle mouse button and then drag it wherever you want to turn it. So this is pretty much how we play around with the view. You can also right click and say orient view and then try to get it from a certain angle. There are a bunch of ways to move the screen around. You can also roll the mouse button to zoom in or zoom out. To select some faces, you can put your mouse over it and then click on them. It's going to highlight them. You can even do like a drag to select multiple faces or features, and so on. So now that we know how to move around to get your part in and out of the screen, we can look at actually creating one. So I'm going to close this one over here. and we are going to create a new file. So to create a new file, we're going to go in the top left corner over here on New. And from this drop-down window, we're going to see multiple options. So we do have options like a model, an assembly, sheet metal, routing, electrical, routing, logistics, and so on. We're not going to look at those right away. Those are more advanced topics that we might be able to look at individually or maybe in a team, whether we plan on having this kind of detailed CAD or not. But for now, to create a part, you just click on the model. Here you can change the name of the part itself, and you can change here the folder on which you're going to save it. So to create it, you can just click, after you click on the model, you can just click OK. And this is the empty file that we just created. As you can see in the middle, we have our initial coordinate system. So this is where we base the entire part off of. It is useful sometimes when you have an assembly to have the coordinate system of a certain part aligned with another so that they can like fit in right away when you add them on an assembly. But for now, we're just going to use it as basically a datum point. On the left over here, this bigger ribbon, you're going to see that it kind of changed. So this is where we're going to see all of the steps of the parts that we're going to make. This is basically the model history. So here, the model views, we're not going to see them right now. So these are basically just the views of the model that we can have like preloaded. For now, this is not really useful. We're not going to use that right away. Same thing with cameras. This is more for rendering tools and so on. Right now, what we really want to look at is model history. So to create our first part, what we need to know is basically that there are multiple modes in CADing. And to create an actual shape, the first thing to do is to create a sketch. And a sketch is basically, so actually you're going to see on the top left here, this is where you create a sketch. And a sketch is basically a 2D drawing of something that we're going to extrude in 3 dimensions later on. So to start the sketching process, we can just click on sketch. And from here, you're going to see on the initial coordinate system, the bunch of like the 3 datum planes that are on the coordinate system. So this is pretty much not super relevant for us now. It might be later on as we go through conventions and so on, but for now we can just click on any one of them. So if we want to sketch on the top plane, we can just click on top. So oftentimes, actually, a little side note, it might be difficult to click in the middle of the object, and to select it, it's actually easier to go on the edge, especially datum planes. So to select it, you can just click on the edge. And you're going to see here on the new little window, it says that we have selected a sketch plane or face. From here, this is where we are in sketch mode. So there are multiple different modes, and the sketch mode is basically where we have different tools made for sketching particularly. So this is where we create the shapes themselves in 2D. And those shapes, we are later going to be able to extrude them into 3 dimensions. So to create the part that we looked at earlier, which was, actually, let me open it again. I just want to share it with you guys. So, actually, I need to be out of sketch mode to open one. A side note. So what we want to do today is just to create a part like this. Now, there are a ton, actually, there's an infinite amount of ways that we can create this part. And the art of CADing basically just, it tells you what is the easiest way. As you gain experience, you're going to see different ways to create the same part, and that's how you're going to get faster and faster at creating parts like these. So to create a part like this, first off, I want to show you guys the extrude function. So let's go back in sketch mode. So when we're in the sketch mode, to create, oh, now we gotta, oh, actually, let me just go back in the previous sketch. So short thing that happened here was that I accidentally created another sketch, but now that I'm out of the sketch mode, to go back into the sketch mode, I can just double click on this icon here from the model history. And now it brings me into this sketch right here. And as you can see, the tools have changed. So we are now in sketch mode. So to get out of sketch mode, you can just click on finish. And that's what I just did earlier to try and open the other model. But this is basically how you do it. So to start things off, if we want to create a part like that, we are first going to need a circle. So here you're going to see there are multiple ways to create a circle. And just like with any other shape in here, there is going to be like an option on how to create the certain shape that you want to create. So for now, we're just going to use the circle by center and diameter. So we can first click on the sketch origin, which is the first coordinate system. And this is basically our datum point. So this is where everything is based off of. So once we click, we're going to be able to see that the circle appears, and we can choose the diameter as well. So once you click again, it just locks in place, and that's how you create your first circle. All right, so to dimension the part, the circle itself, you can look for the rapid dimension function over here in the lookup command. And once you click on the circle, you will see that there are multiple sections over here. So you can choose, for example, the center of the circle, and then the object would be like the edge of the circle. And this is where you can dimension it. Or you can, for example, if we were to cancel this, we can press on, so we can right click it and press delete. If we rapid dimension it by just pressing on the circumference, both objects will be locked at the same time, and this is where we're going to get the diameter. And then once we place it by clicking wherever else, we can just close this window. And to set it to a set dimension, we can double click it. And from this window, this is where we can say we want it at 2 units. So to scale it, this is how we do it. Now we can just scale it back up. And here you're going to see that the sketch is now fully defined. So what this means is that there are no potential movable components. So all the dimensions that needed to be set are set. For example, if we were to move this circle out of the range of the center of the part itself, we're going to see that now the sketch is partially defined with one movable curve, which is the center of the circle. So the diameter is set by the rapid dimension function, but we're still able to move it wherever, and it's not precise movement. So in terms of good practices, we never want to leave a sketch partially defined. We always have to fully define it. So to get back to a fully defined sketch, we're going to need to set the circle back to the center of the part over here. And now we can use something called geometry relations. So instead of rapid dimensions, to set some kind of geometry relations, the options are on the top over here. When you're in sketch mode, you're going to see them appear. So we have options like making two lines collinear. We have options like making them coincident, making something horizontal, vertical, tangent, parallel, perpendicular, equal, symmetric, or make a midpoint aligned to something else. And from these functions right now, what we're looking for is to make coincident. And it doesn't have to be lines, so it can be a point over here. So you're going to see two selections that need to be filled. So the first one would be our center of the part, or actually, let me just go to the center of the circle first then. And then we can select the center of the part. And you're going to see that the sketch now wants to move to this location. From there, you can click either apply if you want to set another geometric relation, or OK if this is the last one. So if you click apply, the window will stay open and you're going to be able to choose something else. And if you click OK, it's going to close it at the same time. Now that our sketch is fully defined, this is where we can make some 3D shapes happen. So to get out of sketch mode, you can just click on the finish button right over here. Now you're going to notice that our sketch is just in 2D. So if you move around using the middle mouse button again, you're going to notice that it's pretty much just like a ring for now. And to set it back to the closest orthogonal view, you can right click and drag to the left. So this button over here says snap view, so it orients the view to the nearest orthographic view. So to make it cleaner, you can just do that whenever you want to switch up. So if we do that again, we're going to see that it just brings us back up to the cleanest orthogonal view. Now, the next thing to create the actual 3D shape is to do something called an extrusion. So the first function that we're going to look at is extrude over here. So this is the simplest function that we have. You're going to use it pretty much all the time when you're CADing. There are other functions over here that are all really useful and that we will look at later on, but for now, extrude is our best friend. So to extrude this shape, well, actually, first, what an extrusion is when we take the shape and we translate it it's perpendicularly to the sketch to create a 3D shape. So something perpendicular to this sketch would be the Z direction. And this all depends on what face you chose when you sketch for the first time. So if I want to say like sketch again, depending on the face that I choose, the extrusion is going to be in a different path. But now I'm going to cancel it to not create another sketch. So to create an extrusion from this part, you can either click on the extrusion, which is going to select it here in the model history, and then click extrude. And you're going to see this kind of 3D shape appear. Or you can directly go on extrude and then select the curve, which can be either in the model history or it can be on the visualizer. From here, we can say that we want the start of the extrusion to be at 0, which is the exact place that our sketch is. And then the end distance would be 25 millimeters. So it would be 25 millimeters up. Now we can say, for example, I want it to be 1 inch. Hold on. 1 inch. Hold on. 1 inch. All right. Weird syntax, but basically, if you want it to be 1 inch, you can just write 1 in, and it's going to convert it to millimeters right away. So you're going to see here 25.4. Or you can just say, I want it to be 25, and it's going to assume millimeters because of the units that we chose earlier in the units manager. Now, if we click OK, we're going to see that we now have a 3D shape. So it's looking a lot more like the model that we have over here. The next thing would be those cutout parts. But what I do want to show you guys first is how to do a revolution. So here we're going to cancel this feature and we're going to cancel this sketch. And for the revolve function, I really just want to show you guys how it works. So it's a bit different to the extrusion function. But here, let me go back into a sketch. So here I'm going to create a sketch. And we're going to choose the right plane. And from here, the sketch that we want to make to have the exact same shape would be a rectangle. And I'm going to show you guys why in a moment. But basically, rectangles work pretty similarly to circles. So we can either choose 2 points of the 2 corners, or we can go by 3 points, or like from the center and so on. There are a bunch of functions for the rectangles that you want to make. but here it is. We can just choose to set the part directly on the center of the coordinate system. We can directly choose that point being the first one. And from here, we can drag it out and create the rectangle that we want. Now, if we close this, we're going to see that the sketch is partially defined. So we need to set the dimensions. And now you're either going to see the rapid dimensions function over here on your top bar. Sometimes it's over here, but it's in the solve function. So you're either going to see it here, or you're going to need to look for it in the lookup command. So rapid dimension. And from here, we can say, I want this line, this curve to be dimensioned. So we can click on the middle of the curve to dimension it. And here, when I click anywhere else, that's where I set it. There's another option where, here, let me cancel this dimension. We can have two selections. So we can say, I want this point to be at a certain distance from this point, and it does pretty much the same thing. Depending on the design motivations, you might need to do different rapid dimensions and so on, but that's not really important for now. You're going to see it as you get more experience. And to actually change it, you can now double click on the distance, and we can now change it back to, for example, 1 inch. Or we can just say 25 millimeters. If we go back, hold on. So now I created a variable, but let me just... Or we can just, delete it and go back to our function of having 2 points. And then we can say 25. And to dimension the other part over here, we do pretty much the same thing. And then again, it doesn't have to be points. You can choose curves. So for example, I want this curve to be at a certain distance. So now we're going to choose the other object being this curve. And it's going to do the same principle. So if I click anywhere else, I'm going to set the dimension in place. And to dimension it, I can cancel the drop-down window over here and double-click it, where we can say I want the diameter to be, the radius to be 100. And from there, we are going to see that our sketch is now fully defined. So this is what we want. Now we can say finish sketch. And as you're going to see in our model history, it's now set in place. To use the revolve function now. This function is a bit more rare than the extrude function, but it's incredibly useful when you know how to use it and when to use it. It can save you a lot of time in terms of design. So sometimes there's also some manufacturing methods that are based on revolution. So if you want to do an object that's based like that, you can use the revolve function to really mimic it very well. But to create the shape that we want, basically the revolution is going to say, we're going to take this drawing and we're going to turn it around to create the shape the 3D shape that we want. So basically we can either choose the sketch on the visualizer or the model history and then click revolve, or click revolve and then choose these curves. And from here, we're going to see that the curves that are selected are these ones. And to specify which way to turn it around, and you're going to see what I mean as soon as we finish this, we can choose a certain vector by which it's going to rotate. So if we choose this z-axis vector, it's going to rotate around the z-axis. So it's going to make a rotation basically like this. If we choose a y-axis, it's going to rotate like this, and so on and so on. So what we want is to have a really wide base. So we're going to say we want it to turn around the z-axis. And now to specify the point at which it's going to rotate around, we can say that we want it to rotate around the center of origin. And you're going to see now the shape appear as if it had turned around the axis, the the point of origin around the z-axis. So this is the same object that we had, and now we can click OK because we don't have anything else to do. And this is the same shape that we had, but made using a different method. So both methods are really useful depending on what you want to build and what you want to design. Sorry, I just had a message. All right, never mind. So I just wanted to show you guys basically that there are a lot of ways to create the same part, and some ways are more useful, or some ways are more like the actual manufacturing methods, or some are less time consuming, and so on. So before making the part, actually, once you have enough experience, you're gonna try to choose what kind of approach you want to take to the design before actually start the CAD. All right, next, here, to create a part like this, now we want to create some holes in here. So in short, it's pretty much the same concept. So we want to go back into Sketch, and we want to create the squares that we saw earlier. And here we can choose either a face, or we can choose a plane again, or we can choose the same origin, and so on. There's a bunch of options now. So here, if we choose this or plane of origin, so as a side note, we are going to look at the good practices, and according to good practices, we should, as often as possible, try to avoid making a sketch on a plane, on a face, because if the face later disappears when we make another shape, it's going to create a crash, and the whole CAD is going to be is going to need a lot of tune-up. So we oftentimes want to deal with datum plane. So this is what we're going to do. So we can choose the datum plane again. And a datum plane, I might have used it before, but a datum is basically a point of reference. It's basically a reference. So a datum plane is basically a plane of reference. So it's not an actual shape on the CAD, or it's not an actual shape that we're going to use. It's really just compared to this like ideal plane. This is where we want our CAD to be. So we're going to choose this datum plane over here. And now it's going to bring us orthogonal to that datum plane. And from here, we can start sketching again. So for example, we want one rectangle over here, and we want another rectangle over here. And from here, this is where we have to dimension them. So as you're going to see, sketch is partially defined with 8 movable curves. So those are the 8 sides of these squares. And from here, we can use the geometry relations to make our life a lot easier. So for example, we can choose make collinear to make this line over here collinear with this one over here. And then we can click apply, and you're going to see them move around. Actually, I think they might have already been collinear. So actually, let me try to change this. All right, so they're going to stay the same, but sometimes they're not like always attached. So just to be certain that they are set up, we can say, I want this one to be collinear with this one, and then we can click apply, and then we can click this one collinear with this one, and then click OK, because we don't have anything else left. And now we can also use make equal to say that we want this curve, why is it not like equal length? All right, so a bit of differences between the licensed version and the student NX version, but in short, here you can choose the equal length and say, I want this straight curve to be equal to this straight curve. So it's going to create a square. You can say apply, and then we can do the same thing with the other square over here. And then again, apply. And since we don't have anything else, we can just say cancel. Now, what we want to do is basically make them also on this, we want to center them around this center of the circle. So what we can do now is say that we want to make horizontal the center of this curve. So there are points at the center of straight curves in NX. So this is where you can say, I want to choose this point over here and make it horizontal with, now you can see there are 2 points to choose from. I want this point to be horizontal with this center, this origin. So now you're going to see both of them move around. You can say OK. And since we haven't defined the length of the squares yet, they haven't been, they can change around depending on the other dimensions that we dimensioned first. And now to set the actual length, we can again click rapid dimension over here or in the lookup and say we want to have this curve be, for example, now we can close it and say we want it to be at 50 millimeters. It creates a rather big square, but it's not really our concern right now, depending on the design that you have. And if we want to, so as you can see now, they are still movable from side to side. So this dimension isn't set in place. So what we can do about that is to say that another rapid dimension, we want the center of this curve or the center of the square to be at a certain distance from the center of the circle. So as you can see, as I move around, there are different ways to dimension it. But as soon as you click somewhere, whenever you move around it, it's going to stay in that position now. So if we want to have it at 50 millimeters again from the center, this is how we do it. And then we can say again, with another rapid dimension, we want this to be at 50 millimeters. And if we rapid dimension, we want the center of the sketch to be at 50 millimeters from the center of the cube, of the square. So from here, now we can see that the sketch is fully defined. And now we could be in a position to extrude it to remove material. So let's get out of the sketch mode, finish. And now we're going to see the actual sketch on our model. And you're going to see here in the model history, this is our new sketch. So this is the revolve function. This is the previous sketch. And here is our new sketch. From here, we can say that we want to subtract volume, or we can do an extrude function, which would then subtract volume. So it's both the same function, but this one is a bit easier to take, but I'm going to show you guys how to do it with the extrude. So if we want to extrude it, we can say that we want these curves, which is our new sketch, to be extruded in this direction. So oftentimes it chooses the orthogonal direction to the sketch just automatically. And then we can say that we want the extrusion to start at 0, which is the actual plane of the sketch, and we want it to end at 10 millimeters away from the sketch. And now you'll see that in the Boolean function over here, it is inferred the kind of extrusion that we want. But if it wasn't, you can see over here that you have multiple functions. So unite, what unite does is that if we want to have, for example, if we want to add another shape to our current cylinder, it's going to merge these two boxes to the actual cylinder. If we choose subtract, it's actually going to remove material instead of combining it. And there are a bunch of other functions, but they're not really useful for now on. The best one is inferred because it actually automatically kind of guesses what you want. So oftentimes you're going to see inferred over here, so it's not really much of a problem. But what we want to do is to subtract it. So you're going to see it's the same it's the same logo as the subtract function over here. So it's pretty much it's the same function, just we go to it in different ways. And now if you press OK, we're going to see that it actually removed material over here. And this is what we see with our new extrude, which is the removal of certain material. So now we're pretty much at the same point that we are here. But I also wanted to show you guys that there's a different way to make symmetries like this in NX. So if we start it over again, we say delete, and we say, actually, if we go into this sketch, I can just delete these curves like this, or actually, I think this is a good time to show you guys. Here we have another function called editing, and we can basically trim, extend, or create corners using like lines on sketches. So if you want to say we want to trim a sketch line, we can just use the trim function and basically just cancel it. So you can also, you can just click on it, or you can use this kind of pencil function where whatever line you go through, it actually cancels or removes. So this is how you can try to create custom lines and so on. So depending on the type of line you use, you might have like different uses for it. So for example, actually, let me just make an example of it. If we have a line like this and we use the trim function, it's not going to trim the entire line over here. It's just going to trim the corner over there. So if we want to have something like this, we can use the trim function. We can use the extend function to have something like this. So if you want to extend it, we can say extend. It's going to extend it up until the next line on the sketch. But for now, we're not really going to be using much of these. So it's basically just a side note on the tools that you have as a in the sketch mode. But one tool that is very, very useful is the mirror function over here. So what this does is it basically allows you to take certain lines and mirror them wherever. But the thing is, here, let's click on the mirror function. We not only have to select the curves that we want to mirror. So if we want to mirror these curves, we can just click on them. But we have to select a center line around which it's going to be mirrored. So we can choose it like this if it's in the middle of, if we want it to be mirrored around the center of the part, we can choose the center coordinate system, and it's going to mirror the whole part immediately. So we don't have to do everything twice. We don't have to change the dimensions and so on. It can just be mirrored like this. Another way to do it would be to create what's called a reference dimension. So let's go look at what a reference line or reference dimension is. So if I want to have a mirror around a line that's not already there, what I can do is here, I can create a line and say I want the line to go from the top corner of the base of the cylinder over here all the way to the bottom of it. So now if we were going to try and extrude this, we would get an error saying that there's a line that doesn't result in a closed shape like this. So we couldn't be extruding it. Even though if we do want to mirror, it would still work, right? So you can see like it would still work, but we wouldn't be able to extrude it just because this line over here doesn't result in a closed surface. So what we do in this instant is that we can right click on the line and say we want to convert it to where's the convert to reference? Let me just find the function. As always, when I'm lost, I can just use the lookup function over here. So if we say reference, there it is. So convert to or from reference. And here we can choose the actual line. And you're going to see that it's going to turn into a dotted line. So as you can see over here, the dotted line is our reference. So it's the same thing with drawings and so on. These lines are not going to be used to extrude. They're basically just there to create some geometry for us to refer off of. So if we press on the mirror function again, we can select this, select the center line, which is our new reference line, and it's going to create a mirrored square over here. And from there, it's going to, we can use the same extrude function and have, so it's going to save like the parameters from our previous function. So it's really useful if we do the same thing multiple times. And we can just click OK. And from there, it's going to create the same shape. So another thing is if you want to change the sketch right now, you can see over here that I removed the extrude before changing the sketch. It doesn't always have to be the case. So if I want to change the sketch while the extrude is still there, and for example, if I want to have it at 35 millimeters away from the center, or I mean, this is actually the distance for the squares. If I want the square to be only 35 millimeters by 35 millimeters, I can change it, click finish, and the extrude function will stay with the same curves. So that has to be taken with a grain of salt. So for example, if I go into the sketch and I trim a corner, here, let me just trim a corner, and then I go back, we're going to have an error because it can't extrude anymore because it's not a closed surface. All right, so now we can press Control Z and go back to what it was before. But in short, the order in this model history does have an importance. So if, for example, you sketch something and you base a dimension off of a previous extrusion, then you're going to always need to keep it below the reference extrusion. But in our case, since we use the datum plane, we're free to just move around the sketches and move around the extrusions. So this is basically how to create your first part. So it's really, it's not that complicated. It just requires a lot of practice. And as you get used to the software, you're going to see a lot of new techniques. And you're really able to let your creativity shine when you're used to the software enough to know what kind of functions would help you make a part in half the time that it would to someone else. All right, so to keep going, now that we've done our first part, some highlights on what to do when first tackling on a CAD project or a CAD task or something like that is to look for certain things that would make it easier for you to CAD. So you don't want to spend like your entire time producing like certain dimensions and so on. So one trick is to look for symmetries. If anything is symmetric, we can use the mirror function. There's also patterns. If you have patterns, you can look for a pattern feature. So that's another function that we're going to show you guys in CAD 102. Another thing is to plan out the easiest method to create the part before jumping in. So if you have a cylindrical part and you want to create something that has like curves on the cylinder, or maybe it has like certain chamfers and so on, it's a lot easier to use the revolve function than to use the extrude function and having to go like step by step. So these kinds of things, they do come with experience, but it's always a good way to start a plan. And next, we also have to be sure of the differences in dimensions depending on the sketch. So if you sketch two parts together, the dimensions of one sketch when united with another might be different. So you always have to be careful on the dimensions. So that's just a little note, as sometimes they do kind of, if, for example, you have two like shapes one on top of the other, then the total height will be like one plus the other. But I know it sounds obvious, but sometimes like when you're CADing, depending on what kind of steps you take, it can lead to confusion. So I do recommend keeping track of the dimensions. Next, we're going to look at the good practices. So what you can do in NX is that you can actually name your sketches and extrusions. So if you want to say, that this is actually the holes or like the holder of something, we can click on this, right click on this extrusion and say we want to rename it. And we can say over here that it's a groove, for example. Or if you want to rename a sketch, you can say that this is the groove shape. Little type over here. Nice. When you have like like 20 sketches in a row, this is when the sketch names are really useful, because you can just look at them and say, okay, this is the one that I'm looking for, this is the one that I'm good for. So it does help people when they're looking at your sketches, or it does help actually you if you're looking for something that's easy to change. So I do recommend naming. It's actually a good practice to name your extrusions and sketches and so on. Another thing, actually, let me just go back to this thing over here. Another thing is to keep sketches small. So, for example, you might have something in this sketch over here. We might have something like, in a certain part, we might be looking at something like 100 of those squares, for example. If we want to have 100 of those squares, we don't want to have to dimension each one of them individually. Even if we pattern it, there might be like some differences here and there. All right, sorry about that. I had the sketch not fully defined because the center line over here was able to move around. But in short, what I just did was that I geometrically relationed it to the center of the sketch, or the center of the circle actually, and then dimensioned it to be the exact same size. There are options to, for example, put it on the quadrant of the circle and then put the other end of the line on the other quadrant. But again, multiple ways to do things. Now, what I wanted to say is that basically, if you have 100 of these squares all placed like all around, and you have something that's not fully defined, you're gonna spend hours looking for that one little square that's not defined. So if you can see on the sketch right away, so if you divide it, for example, into like bunches of 10, depending on their functions or so on, it's going to be a lot easier to see over here on the model history which one is not completely defined. So if we go back to finish, so if we, for example, if we click on one and we see that the sketch is fully defined, we're going to assume that all those squares are defined and so on. So it's always a lot easier to keep your sketches small, just because if you do have a not fully defined sketch, it's going to be really hard to spot where the undefined section is. And the next good practice is to use datum planes for extrusions. So when we used our first extrusion over here, we used a certain distance. So it's not a bad practice. It's doable. But for example, if we want the whole extrusion to go through the base, instead of saying until selected and then we choose the face. So this we can do this, but this is considered a bad practice, because if we have another object on top of thing, or another extrusion on top of this face, and the face disappears, it's going to create errors. So instead of having up until selected, what we want to do from the ground up, what we want to do is create a new datum plane that's not on the datum coordinate system. So to create a datum plane or a datum coordinate system or datum axis, you can go on the top left corner here. So now we want a datum plane. And from here, we want to base it off of the original coordinate system, so that we, again, avoid any reliances on faces. So if we want something that's on the z-axis, we're going to choose the xy plane. And you're going to see here, it's going to create a little datum plane, and we can choose the distance that we want. So if we want something that's halfway into the actually, if we want to choose something that's all the way through this shape, we want to say that it's 25 millimeters away. When you're creating an extrusion, you can only rely on parts that are before it in the model history. So as you're going to see over here, the datum plane is grayed out. So we need to move the datum plane before the extrusion in the model history. So if we go back into our groove, we can see that if we select until extended, it's going to be pretty much the same function, but here we can choose the datum plane. And now, even if this face disappears, the holes are going to stay the same size and they're going to stay there. So it's not going to create any errors or crashes. So that's a good practice in terms of CADing. Next is to, again, avoid using an extrude up to a face. And also, a final thing of good practice is to bunch up all of the datum planes first, all the sketches second, the extrusions third, the holes. So if you use any holes, they're often going to have crashes, so we want to put them at the end. And finally, we want to put edge blends at the very bottom. So that way, if any edge disappears, it's not going to create a whole crash, and we're just going to be able to remove that one. So what an edge blend is, actually, let me show you guys before, is if you press on that button, you're going to be able to choose an edge. So it's very, very useful, actually, an edge in terms of reducing stress concentrations. So squares like these are going to have massive stress concentrations here. Again, another reason why we might use edge blends is because, as you're going to see, sometimes we machine parts with something called a CNC mill, which is a computer controlled, pretty like a drill, pretty much, that goes around and shaves off material. And it's impossible to make this kind of cut or this kind of sharp corner on the inside of a part with that kind of manufacturing method. So what we want to do is add a corner by having an edge blend over here. Now we can adjust the radius with this function. So if we press enter, it's going to change. Say I wanted to 3 millimeters. Depending on the size of the tool that you use, or depending on the stress concentrations, it would change. And now you can select different edges again from this window. So if you want all of these edges to have the same radius, you can just go around. All right. So if we go back out of this function, you're going to see now that they all have rounded edges. And as always, keep those at the very end, because it's very easy for an edge to disappear out of a shape. So they crash very, very often. By keeping them at the end, that's how we pretty much prevent too much work from this kind of crash. All right, next thing and final technical tip for this video is, as a good practice, oftentimes what we use are variables. So what those are is basically a way to change the dimensions of multiple components at once. So it makes it a lot easier to change a design or to adjust something depending on what you're going to see. So how to use variables? Well, you just go to our sketch over here, and you can create a variable in multiple different ways. One of them being directly into the sketch. So if we double click on this, actually, let me double click on the diameter of the sketch first. All right, let me go back to the actual base. So this is our radius over here. If we want to create a variable based on the radius, what we can do over here in the distance mini box, we can say base radius. So the name of the variable is equal to 100. So now you're going to see that our distance is now base radius. So if we go back out of the sketch by clicking finish, we can go into the groove shape sketch and say, I want the squares to always be at base radius divided by 2. So they're always going to be at the halfway point of the radius. So now if we go back and change base radius, to change the variable itself, you can go over here in Tools, and in this function over here, you can click on Expressions. Now here is another way to create the variables. You can say base diameter, and here you can say that it's base radius times 2. So that's going to create a value of 200. To change the actual base radius, the base radius value, you can come over here and say that I want it now to be 200 of radius. So this red over here means that it hasn't been saved yet. So we can click apply. Now everything's been saved. And if we go back to our model, you can see that even though the radius increased by increased 2 folds, you're going to see that the square holes here are still at the halfway point between the center and the radius. So it's a relatively complicated process, but it's very, very useful in terms of if you want to change, if you know you want to change your design a lot, or if you want to have maybe multiple iterations, very useful to make quick changes. So it's just another trick. Again, variables can go increase like pretty much infinitely complicated. You can have if statements. So if you want to, if it's above this kind of diameter, you can have 3 holes or 4 holes. And if you have 4 holes, then you can create this or unsuppress a new shape or so on. And actually, as a side note, suppressing a shape is basically just, if we go into suppress here, it's basically just removing it temporarily. So now you're going to see that the edge blends are removed. If we go to unsuppress, we're basically just adding them back up. But in short, variables, very complicated, but very, very useful and very helpful to anyone who's looking to use your design afterwards. And it's basically a good way to make your design future-proof. Now, to finish things off with the team conventions, what we're going to be looking at is basically how we name our files. So if you're going to see over here in the corner a little icon of a tablet and a pencil, that means that the part has been modified and not saved. To save it, you can go over here in File and click Save. Now you can save, using this save basically just saves it at the current location. You can use Save As to change the name and the location. The save work part only and the save all are basically functions of savings, but for assembly. So we're not going to be looking at those yet. But for now, we can just use the save as. And as a convention, here we're going to see that to save an actual part, so that's the only thing we're going to be looking at for now. In CAD 102, we're going to look at assemblies, but I just wanted to highlight it right away. To save the part name, we're going to use this template over here. So this name is actually going to be, for example, structures, and then the part name would be cylinder plate or something along those lines, to highlight the fact that it's a part, because in NX, the ending over here is always the same. So we just want to say that this is the base part. And now we have the version over here, which is 1.0. And as we make small changes, we can increase the 1.0 to 1.1 or 1.2. If we make a major change, then we can change to v2.1 again, and so on, so on. So now we want 1.0. Now we save it, and now we can see the name has changed, and we're good to save. So for assemblies, it's pretty much the same thing, but we want to replace the part by assembly. Next, when you're looking at the drive, you are going to see, odds are, you're going to see multiple versions of the same part as a v2 point whatever. And we do recommend keeping at least 2 previous versions of every part. So if you're at v4, we want you to keep at least v3 and v2 in the archives of the drive. For example, the V1 could be discarded in terms of storage capacity. It does help a lot to, clear out the older versions as we go along. But to keep the previous two versions really does help in case our new version doesn't work anymore. So it's always super, super important to keep some versions from before. The final assembly will be named mastercad_MVF, which is make a vertical flight, and then the year of design followed by the version. And then again, even though it's an assembly, it's going to be .prt, which is the NX equivalent. And finally, what we're going to be looking at next for CAD 102 is assemblies, drawings, which are very useful for manufacturing methods, advanced function like the pattern that I talked about earlier. And we are also going to look at doing a lot of practice. So we are going to be working on getting every one of you guys involved in the actual CADing process. And then we're going to talk about how to keep learning, how to move on to finite element analysis and computational fluid dynamics and so on. So if you're interested in all of those subjects, I do really recommend going to CAD 102. But on that note, that concludes our CAD 101 meeting. And if you have any questions, feel free to send them to me. We are going to be sending this recording to our drives, so you might be watching it right now on the drive. But either way, if you do have questions, really don't hesitate to message me, because CAD is very, very important in all the functions of engineering. And on that note, I'll leave you guys to it and have a nice end of your day.